All right, this screencast is to go over the warm-up problems that we were in the middle of yesterday, and we need to continue today. And then I got word that apparently there's volleyball pictures or something like that. So anyway, I'm recording it so that if you miss that, you can go back and do these examples with me. All right, we left off on number 12 on page 67. And it says, in one day, Annie traveled 5 times the sum of the number of hours Brian traveled in 2. Together they traveled 20 hours. Find the number of hours each person traveled. All right, so there were 2 equations in that sentence. The easier equation was actually the second sentence where they said together they traveled 20 hours. Well, whatever number of hours Brian traveled plus the number of hours that Annie traveled, those 2 things are equal to 20. Then the first sentence said that Annie traveled 5 times the sum of the number of hours Brian traveled in 2. So Annie traveled 5 times the sum of what Brian traveled plus 2. And then what we did is we realized that, well, Annie, however many hours she traveled, that's equivalent to all of this. Because what we need to do is we need to get down to one variable so that we can solve. So we're going to take what Annie's travel time is equivalent to, and we're going to put it in there for A. Because remember, A equals all of this. So let's put this in for A. When we do that, we wind up with this equation. Brian plus all of this, remember, for Annie, equals 20. Do the distributive property. And we wind up with Brian plus 5b plus 10 equals 20. After combining the b's, we have 6b plus 10 equals 20. Okay. Ignore this down here. Somebody had asked me, well, what if the b was on the other side? Okay. So we're going to pick up where we left off at the end of class yesterday. So next step is for me to subtract 10 on both sides. 20 minus 10 is 10 over here, 6b there. Okay. To get b by itself, you have to divide both sides by 6. b equals 10 over 6. All right, guys, this is an improper fraction. Let's make it a proper fraction. 6 will go into 10 one time with 4/6 left over, or if we reduce that fraction, 1 2/3. Okay, so Brian traveled 1 2/3 of an hour. If you guys remember, an hour is 60 minutes, so 2/3 of an hour is going to be 40 minutes. Okay, so Brian traveled 1 hour and 40 minutes. All right. Now we're going to go back and revisit that equation that said whatever Brian traveled plus whatever Annie traveled, those 2 things added up to 20. And I'm going to put the 1 2/3 in here for Brian plus whatever for Annie equals 20. So to find the number of hours that Annie traveled, I'm going to subtract 1 2/3, subtract 1 2/3. Little bit of mental math. I know that 20 minus 2 would be an even 18. So 20 minus 1 2/3 is going to be 18 1/3, because these 2 things add up to 20. So Annie did a whole lot more traveling, because she traveled 1 1/3 hours, or, sorry, not 1 1/3, 18 1/3, 18 hours and 1/3 of an hour, 20 minutes. Okay. All right, next we're going to hop over to page 74, and we're going to start looking at some things in lesson 3. It says solve for the indicated variable in each mathematical formula. Okay, it's going to be really important that you remember the two basic principles of rearranging or moving anything in an equation. To move something, you do the opposite operation, and whatever you do to one side, you have to do to the other. So I'm going to just work in here. I might overflow into one of the other problems, so that's okay. But so area is equal to 1/2 base times height, so this must be the area of a triangle. Would you guys agree that 1/2 base times height is the same as saying base times height divided by 2? Okay, because it's really 1 times b times h in the numerator, and then 2 is in the denominator. All right, so if I look at it this way, I see that the first step is that I need to multiply by 2 to get rid of the denominator here. All right, so after that one step, I have 2a equals b times h. B times h, they're multiplied together. So the inverse operation is what I need in order to get b by itself. So I'm going to divide both sides by h. Okay? And as I said in the lesson, I usually like, here I'm going to draw this down here. I usually like having my single item on the left so that I can kind of read left to right. So the base is going to be equal to 2 times the area divided by the height. So you haven't solved anything because you have a bunch of letters. But, you know, if you were given some information in a problem and you weren't asked to find area, but you were asked to find base, then you would have to rearrange the formula before you could proceed. All right, let's go to number 6. This says that surface area is equal to 2 pi r squared plus 2 pi r h. And they want you to solve for h. All right, so the first thing I'm going to do is I'm going to move this whole entire term that doesn't have my h. I'm just going to move it by subtraction to the other side. So I'm going to have surface area minus 2 pi r squared equals 2 pi r h. Then all of these things are multiplied together, 2 times pi times r times h, and I want h. So since they're all multiplied together, I'm going to divide by the 3 that need to move. And then I divide the other side. I have to divide the whole entire other side by 2 pi r. Okay? Now, I can't cancel any of this. That's not y'all's. I can't cancel any of these because it doesn't apply. Like I only have a pi and an r and a 2 over here. I don't have it here. It's like I could not pull it out of both of these and have it like undo the distributive property. If you could have done that, then you could have maybe canceled something. But right now we're just stuck with it as it is. So height equals surface area minus 2 pi r squared, all of that over 2 pi r. Okay, once again, maybe you have some information and you've got the surface area and you've got the radius and you've got, you know, obviously you know pi, but they're asking you to find height this time. Well, that's what you would do. That's what you would find. All right, number 10. We have, I don't even remember what this formula is. So we have capital C equals WTC, lower c, divided by 1,000. Okay, I don't love the fact that they're using C's, but one of them's capital, one of them's lowercase, so they're two different things. And we want to solve for W. Well, the first thing that we need to do is get rid of the denominator. So I'm going to multiply both sides of my equation by 1,000. When I do that, I have 1,000, capital C, equals WTC. I want W by itself. All three of these are multiplied together. So divide by TC, divide by TC. Okay, and just remember, I don't love this because that's lowercase and that's uppercase, and you might think, oh, they cancel, but they're two different things. Okay, but they do cancel over here. So when you clean it all up, W equals 1,000, capital C, over little t, little c.